We're going to look at simplifying radicals. We're going to start with the square roots to remind ourselves how we looked for, on the square root we're looking for pairs. On the cube root we'll look for triples, and the fourth root we'll look for four of a kind. Once we have those, we can pull them out of the radical. So if you see 72, most of us look at 72 and we see 8 times 9, and 9 is 3 times 3. There's a pair. 8 is 2 times 4, and 4 is 2 times 2. So we have two sets of pairs here. We've got our 3s and our 2s, and then we have the lonely guy who's going to stay under the radical. So we have the 2 comes out front times the 3 that comes out as well, the square root of 2 left over. So we have 6 square root 2. For the cube root, we're looking for a triple. So 54, 9 times 6, 9 is 3 times 3, 6, 3 times 2. Now we see we have a triple here, and then we have a guy left over. So the triple is going to come outside of the cube root, and I get 3 cube root of 2, and that's my final answer. When we have fractions under a radical, we have to take the radical of the top and the bottom. So I get radical 3 over radical 4. Radical 4 is a perfect square, so I can leave it as radical 3 over 2. Okay, this is a nice one where it works out so I don't have to do any rationalizing. We'll talk about that on the next slide. The cube root of 8 over 27, same thing, a cube root of 8 over cube root of 27. Cube root of 8 is 2, cube root of 27 is 3, so my answer is 2/3. Alright, so here's where it gets a little bit more complicated, a little bit harder for us to see, is when we have to rationalize the denominators, because I can't take the cube root of 3 or 4. So I have to find something to multiply by so that when I multiply by it, the denominator becomes rational, meaning I can take the cube root of it. So I'm going to first look at this as the cube root of 3 divided by the cube root of 4. And the radical is allowed to be in the numerator, but not in the denominator. So the first thing I see is that we can look at this as a cube root of 2 squared, because 4 is 2 squared. And I want to know, what can I multiply by so that the denominator will have a triple? I already have 2 2's, and I need 3 2's. So I'm going to multiply by the cube root of 2. And whatever I do to the denominator, I have to do the numerator. So I have the cube root of 3 times the cube root of 2. When the indexes are the same, I can multiply the numbers underneath. I get the cube root of 6 on top. And on the bottom, I get the cube root of 2 cubed, which is equal to 2. You could think of that as the cube root of 8, which is also 2, but I like to look at it in exponential form. So the cube root of 6 over 2, and that's your final answer. And let's look at the second one here, the fourth root of 32 over 27. So I'm going to first split that up. I notice that I have the fourth root of 32, and 27 is 3 cubed, so I'm going to write that as the fourth root of 3 cubed. Now it's the fourth root, so I need 4 of a kind. So if I have 3 3's, I need 1 more. So I'm going to multiply by the fourth root of 3. Fourth root of 3. Whatever I do to the denominator, I have to do the numerator. So I'm going to write this as a fourth root of 32 times 3 over the fourth root of 3 to the fourth. And I can simplify that numerator, so let's look at that real quick. 32 times 3, obviously 3 is just a 3, but 32 is 8 times 4. 8 is 2 times 4. 4 is 2 times 2, and again 2 times 2. I'm dealing with the fourth root, so I need 4 of a kind. So we're looking at having 4 2's, so that's going to come out, and then this 2 and this 3 are left under the radical. So I'm left with 2 fourth root of 6 on the top, and the fourth root of 3 to the fourth. That's this right here, the fourth root of 3 to the fourth, the 4 power and the fourth root cancel, and I get 3 in my denominator. I can't simplify the 2 and the 3, so that's my final answer. All right, let's look at this one. This next one has a variable in it. Doesn't mean we look at it any differently. I have the fifth root of 5. That I can't do, so fifth root of 5 over the fifth root of 4 can be written as 2 squared, so let's write it that way so that we can see how many more we need. We need 5 2's and we're going to need 5 x's. So what is it going to be that we need to multiply by? And remember again, whatever we do to the bottom, we must do to the numerator. So I have 2 2's, I need 5 2's. I have 2, I need 5. So that means I need to multiply by 2 or 3 more 2's. So 2 cubed. And the x's, I have 1 x, I need 5 of them. I need to multiply by x to the 4th. So whatever I do to the bottom, I'm going to do to the top. X to the 4th. And when I multiply that together, I get, let's see, where do I want to write this? Fifth root, we're going to go 5 times 8, x to the 4th. That's my numerator. There's no groups of 5 in the numerator, so I'm going to not simplify that. And then the fifth root of 2 to the 5th, x to the 5th. Because once I add my exponents, I've got 5 2's and 5 x's. That's my ultimate goal in the denominator there. So I have the fifth root of 40 x to the 4th over 2x. Because our fifth root cancels out our fifth power, and our fifth root cancels out this fifth power. And our final answer is the fifth root of 40x to the 4th over 2x. I cannot simplify into a radical, so the only thing I can simplify with is what's out front of the radical. And so that's my final answer.